Hello everyone, in this video I want to explain the main differences between relational database and DynamoDB in particular, which is part of the so-called NoSQL world. This difference will help you during the data modeling process of Dynamo, which is quite different from a SQL database. And the first concept we want to introduce is the data normalization. Okay, so starting from this example, we have like employee table with employee ID, name, city, and department. We're going to transform this table using the first, second, and third normal form. So we can already see that for example, the department one has different values on one column, which usually is not like compliant with the normalization form. So yeah, the idea is to transform this table going through each of the steps from first to third normal form. So the first normal form rule says that an attribute, so like a column on the table, cannot hold multiple values. So you should hold only atomic values, which means can only have one value basically in the column. And as you can see, like city columns is fine, but the department one contains more than one value. So for example, this row is not first normal form compliant. To transform the table to apply to the first form, we need to split those values into another table, and we can do like, we can create a new table with employee ID and the department attached to it, and then we're gonna list the different department where the employee is from. And the idea, like the final form of the table will be this one. So we have the first table where we remove the department column to apply to the first normal form, and then we're gonna have another table with employee ID and a different department where it stands for. So for example, the employee ID 2, which was the one that had 2 departments, fin and support, is gonna have 2 rows in this new table, because Jane Doe is gonna be from, he works for finance department and also for support department. Same thing for Harry Potter, for example. This is like the first normal form of the table. Now let's see how we can move from the first form to the second form. So the second rule is that all non-key attributes must depend only on the primary key. So here we will see that in this new table that we created, the department attributes doesn't just depend on the employee ID. So we have to change this. The idea is to create a new table where we have the department name linked to a department ID, and then the employee ID linked to a department ID. So we're gonna split this table again. We're gonna create a new table where we have the primitive values for the department. So it's gonna have department ID, name, and the description if you want to add it. And then we're gonna have like a link between the employee ID and the department with this new table. And then from here we have like a mapping between employee ID and department ID. In this way, the tables apply to the second normal form. After we achieve the second normal form, we move to the third one, and the rule is that basically 2 columns must be independent of each other. So in this case, we will see that it's almost okay, but the city and country are dependent from each other, because if I change the city, the country is going to change as well. So we need to split this table again and move to a new table, which is going to be a location ID, for example. And then we're going to have like city and country. In this way, the employee table will have reference to location ID by this foreign key to the new table. So this is like the process of normalizing the data with SQLize. Now let's see why this process can help, or why we don't need it on DynamoDB. So you might be wondering why you need the data normalization in the SQL database. The first reason is that back in the days like 80s and 90s, data storage was very expensive. Like having 1 GB of memory was super expensive. Now it's not the case. Second reason is data integrity, which means that with data normalization, we know that one value for the item can only be in one table. So we don't need, if we have like a change in the employee name, we know that this item is only stored here. We don't have to update any other table around the database. This ensures like data integrity within the database structure. So now that we have seen the normalization, which is like a big difference between relational and NoSQL databases, the second one is joins. So joins is basically like a connection between tables that you can do when you do a query in the SQL database. The problem with joins is that yes, it's super like flexible and can enable different access patterns for your application, but it's difficult to then scale the database because you can only scale vertically the SQL database, because if you split the database in different machine, you will actually lose data integrity and also lose the join feature. So with SQL, you can only, let's say, scale vertically, which means updating, powering the CPU or memory of the machine, but eventually you're gonna hit a limit on your application. With all these concepts in mind, so like data normalization, joins, let's see how these concepts transforms into the DynamoDB architecture and single table design. The idea behind the single table design is to have multiple entities within the same table. I know that it can sound crazy, because if you are like, used to a SQL database, you will say it's impossible. But with DynamoDB, it's actually possible to have multiple entities in a single table. And you will do that, first of all, using generic key names on the partition key and sort key values. So I would say 95% of the cases you will use like a composite key in DynamoDB. So it's going to have like partition key and sort key, and you can call it as PK and CK. So very generic key names. You wouldn't call it like customer ID and I don't know, department ID, because it's not generic. We want to use generic names, because it's going to be like PK, SK, or primary partition key, sort key. And we can actually allocate different entities within the same PK and SK, so partition key and sort key. For this reason, since we're going to have different entities in the table, we're also going to have different attributes, because the attributes for an employee, for example, will be very different from attributes for a department ID, or for a location ID, or for a payslip. So when you get an item from a single table design table, you need to understand that you're going to have different attributes based on the item that you're getting. So let's start from the SQL example that we showed before, and see how we can map all these entities into one single table. And we're going to use like different steps in order to do it. The first step to take is to list the entity that we had on the SQL design. So in this case, it's like very simple. We have employee, department, and location. The next one is to create an entity relation diagram, very typical from SQL, but at least we have like an idea of the relationship between entities in the tables in the database. So in this case, we're going to have employee can be in more than one department, just for the sake of the example, and department on the other way can have more than one employee. So it's like a many-to-many relationship. Same thing for the location. The employee can have only one location at a defined time, and location can of course have more than one employee. The next one is it's very important to list all the access partners that our application will need at a certain time. So the idea is to really be sure to list all of the access pattern of the application, so we can design the DynamoDB data using based on the access pattern defined in this table. So for the employee entity, for example, we want to get the employee by ID. I suppose that in my application, I will have the employee ID. So I can have like an API call where I request based on the employee ID all the information about the specific employee. Now the access pattern could be get the employee by name. So I only have the name. I want to get the employee ID and all the other attributes of the employee. Same thing for the department. So get department by ID. But another maybe a little bit more complex query will be get employees by department ID. So given a department ID, I want to get all the employees that work in that department. And the location, I just started like an example, get location details. Now that we have the access partners, I want to focus just on some of them, just for the sake of the example. And I want to design the primary key and sort key, so partition key, sorry, and sort key based on those access partners. So for the employee, we do have a simple entity, which is like employee hashtag employee ID. Same thing for the sort key. So if we have to get the employee by ID, we will do a query like, or you can do like a get item query with primary key and sort key equals employee hashtag the ID that we receive from the front end, for example. Same thing for the department. It's like a very easy query to do with Dynamo. A more complex one will be this main-to-main relationship between department and employee. And in this case, we are kind of using a different partition key and sort key design, where we specify department ID on the partition key and sort key employee. In this way, by just querying a specific department ID, we're going to have an item collection with all the employee that are within the same department ID. And if we have to do the same thing, but on the other hand, so getting all the departments for a specific employee, we can just create secondary index with the partition key and sort key flipped. So we're going to have like primary key of the GSI on the employee ID, and sort key of the GSI department ID. And we can do the same query, but with the indexes flipped. So we can get all the departments for a specific employee ID. Let's see how the example looks like in reality. So I use the NoSQL Workbench application to show you the table. I added some sample data, and let's go through, for example, the employee entity. Employee entity has primary key and sort key of the same format. So it has like employee hashtag employee ID, sort key, same thing. Then I added like some attributes like name, nationality, just for, see the example. Same thing for these other three employee. Then we're gonna see the department example, department entity, which has like some different attributes, country and city. And we also have department support and department sales. Now, the very, very interesting design of this table is to see how we can actually get the employees within a department. So as you can see from the design, when you specify primary key department support, so primary key department hashtag ID, you also have in the same item collection, we have both the department details, so country and city, and then here we can have like other attributes, but we also have the list of the employees. So with just one query and specifying the primary key as department hashtag ID, we can get at the same time department details and list of employees of the same department. And the only thing when you design main-to-main relationship is that you have to duplicate some data, like I'm doing here for the name of the employee. If we want to see the same example, but with the like the employee on the other hand, so like getting all the departments for a single employee, we will need to add a GSI on the table, and you can do that going to the data modeler, edit, and you can add here global secondary index. You can actually try out. So it's like GSI, partition key, I can do sort key, and I want to add a sort key as well, which is going to be primary key, projection all. I'm going to save edit, and if we go to the visualizer, you see there's like a different aggregate view. So this is like the main one with partition key and sort key, or the main table. They're going to have the GSI here. So in this case, we do have like employee are only in one department, but if we add like another like department for an employee, let's actually try out. So let's say I want to get this employee 1, 2, 3, 4, 5. I go here and I do like update. I'm gonna add value. It's gonna be employee. So it's gonna be employee here, and let's say that the employee 1, 2, 3, 4 is also on sales. So let's save it, and now we're gonna see on the aggregate view for the GSI that the employee 1, 2, 3, 4, 5 is in 2 departments. So same thing, when you use the GSI, you can get with one query both the employee details and also all departments by employee ID.